Hey kids, welcome to separable differential equations. So recall that we taught you through initial value problems to solve a differential equation. Remember, like if you had velocity is equal to 2t plus 4, that actually is a first derivative, which is a differential equation because it has a derivative in it. And how you solve the differential equation isn't our traditional thinking about solving where we're like, oh, x is equal to 5. No, it just means get y by itself and solve for c if you are given initial conditions. So this process is not going to change. You still are solving just a differential equation. It's just that the form of the differential equation is going to be slightly different. Your differential equation is going to have derivatives in it, but over here, you're not just going to have t stuff. You're going to have something like 2t plus 4 times y squared. So a separable differential equation is one in which you can look at the right-hand side as a product of the independent variable and the dependent variable. That's what makes it separable. It must be true because after all, y prime is actually dy dt with respect to t. So this is normal, this is not. I need to see everything in terms of t. It's kind of like in derivatives when we did implicit differentiation. Remember when we did implicit differentiation, you had to worry about when you had y stuff mixed up with x stuff. So let's go. Solving separable differential equations. So I want you to look at this equation. It is a differential equation because it has a derivative in it. Here is y prime. But notice the right side is a product of, right? It's a product where one of the factors is normal. I'm taking the derivative with respect to x, and there's x stuff. But it is being multiplied by a factor involving the dependent variable. So that's what makes it separable. So step one is unseparate. Keep calm and keep them separated. I used to be hip and I used to be cool, and kids I'd say, who sings that? And they'd all say, oh, it's Offspring, but not anymore. Sigh. So I have to recognize it's separable and then unseparate. So separate the factors, moving all the terms involving x and y to opposite sides. Integrate both sides and then plus c unless someone gives you an initial value. So look at what I've done here. Do you see what I've done with this equation? I'm going to rewrite it over here. dy dx is equal to x squared times y to the 1/2. I divided both sides of the equation by y to the 1/2, which is also, by the way, exponent kings. You go, king. I can multiply everybody by y to the negative 1/2, right? Y to the negative 1/2 times y to the half is y to the 0. I'm sorry, y to the is 1, right? As it is y to the 0, which is 1. But then I have it over here. So notice here I have the derivative with respect to y, and I have y over on this side. I have x over on this side, but I still have a dx thing here. What are you going to do? multiply. You can think of this in two ways. How I get rid of this dx, you could say, oh, I'm just going to multiply both sides by dx and then integrate. Or if you want to be fancy, you say, I'm going to integrate both sides with respect to x, and then these dx's cancel out. But you have to integrate this side with respect to x. But notice when you are done, on the left side, you only have y stuff left, right? So on the left side, this reduced to the integral of y to the negative 1/2 dy, because again, the dx is canceled out, equal to the integral of x squared dx. So you are integrating y stuff with respect to y and x stuff with respect to x, so everything's golden, right? Power up, divide by the power up. Right? Negative 1/2 plus 1 is positive 1/2. Divided by positive 1/2 is the same as multiplying by 2. X squared is x cubed over 3. Technically, there is a plus c on this side and also a plus c on that side. Please don't tell me they cancel out. They're not the same constant, right? This is like constant 1 and this is like constant 2. So I can move this different constant over here, which means I have just one constant, which is why we usually write it like that. Now I'm going to apply the initial condition. So the initial condition was 0, 0. So I plugged in 0 for y, and I plugged in 0 for x, and I got c was equal to 0. Therefore, that's my final answer. Now, I need you, some of you may be feeling a little bit uncomfortable saying, aren't I supposed to get y by itself? No. You don't have to unless you're matching multiple choice or these directions say something like this. That means get y by itself. So I could get y by itself, right? I would divide by 2. And then I would square. Right? I could do that, but I don't need to. Okay, so again, don't freak about only one c. And don't worry about getting y by itself unless someone asks you to, or you're matching multiple choice. So this one, what's nice is they're telling me it's separable. They don't always do that. Solve the separable differential equation, which means I'm going to separate x's and y's on different sides of the equation. And then this is my initial condition or initial value. So I'm going to have to solve for c. That's what the graph of the original looks like. Notice it's not a function, right? Here is the original graph. It is not a function. Its derivative is in terms of x and y. To find the original equation, I need to, this is a derivative, right? dy dx. I'm going to take all the y stuff and move it over to t'other side. Then I'm going to integrate both sides with respect to x. which means I really am integrating 3 minus y squared with respect to y. That's all nice. And integrating 2x plus 1 with respect to x. Plus c. Right? But there's a constant over here and a constant over there. I'm going to collect the constants on one side. It doesn't matter what side you collect them on either. Notice they gave me an initial condition. When x is 1, y is 0. So there's 0, 1 plus 1 is 2, so therefore c is equal to -2. Therefore, the solution, particular solution, given that 1, 0 is on the curve, is 3y minus 1/3 y cubed is equal to x squared plus x minus 2. No, I'm not going to get y by itself, right? Notice I can't get y explicitly in terms of x anyway. Look at the graph. I'm done. Now notice again what this says. What are you doing? They gave me the point 1, 0. There's its tangent line. You know what the slope of that tangent line is? 2 times 1 plus 1 over 3 minus 0 squared, right? Into the derivative, put 1 and 0. 2 plus 1 is 3. 3 minus 0 squared is 3. This slope is 1. Right? And you can kind of see it looks like 1, right? Up 1 over 1, up 1 over 1. But notice what you were given was a rate of change. You knew the derivative. You were given a rate of change, and you came up with an algebra expression. Given one data point. That's pretty cool, right? Let's do this one. Notice this one did not say separable. It just said solve the differential equation. So you like when they prompt you with separable, but they don't always have to. You are now responsible for always looking. The dependent variable is y, and I see a y across the equal sign. This is separable. I need to separate the variables. I have two factors. I need to separate them. In AP rubrics, if this is on long answer and you do not separate the variables, they will not read the rest. They consider that an egregious conceptual error, and they will not read the rest of your work. You do not get partial credit from there. Oops, sorry. So separate. Take the independent variable and move it to the other side, legally. Remember how you simplified? Simplify. Right? Do you see why I did that? I am now going to anti-differentiate with respect to x on both sides. Follow the ruling of algebra. I can do whatever I want to one side as long as I do the same to the other. The dx's cancel out, and then I'm actually integrating secant squared of y dy. Do you see why I like that? This is certainly x squared plus c. And what is the antiderivative of secant squared? Nice. They did not give me an initial condition, so I don't have to solve for C. They didn't ask me to get this into explicit form. I don't have to get Y by itself. I'm all good. Let's do another one. So here's the directions that you see in your book. Solve the differential equation. They didn't say separable. Your solution should be expressed as an explicit function. AP doesn't really use this language, right? They'll say report your answer as y equals f of x. They don't say explicit, but they will write this. You need to understand that means get y by itself in your final answer. This next part is never asked on AP, but it is in your book, so I don't want you to freak about it. If your AP doesn't ask it, we won't either, not on our assessments, but it is a good thing to think about, right? Just because AP doesn't choose to test it doesn't mean it's not an important concept. So of course, the first thing we have to do here is notice, get y by itself. They're asking, the book will ask you about a domain, but they did give me initial conditions. Oops. When x is 1, y is also 1. Oops. So I'm going to do algebra here. Realize that I've got the dependent variable on the wrong side. Integrate both sides with respect to x. Power up, divided by -1 plus c. Let's solve for c. So when I'm when I'm most of the way done, what do I have? I have -1 over y is equal to 1/3 x cubed minus 4/3. You've got most of the rubric points. You have separated and solved the differential equation correctly. You have used your initial condition correctly and gotten the correct C. The only thing you haven't done is gotten y by itself. If this is a long answer and you're running out of time, leave that and move on. Common denominators. I want a common denominator so I can reciprocate both sides. Negate. Just so I don't have to lead with a negative. No, you don't have to do that. There I got y by itself. You took algebra 2 and you paid attention. Can you talk to me about the domain of that? Right? What is the domain? Hello, this was unit 1 of AAF or algebra 2, right? This is a fraction. What can't you divide by? So what makes 4 minus x cubed equal to 0? Woot woot. So there was my final answer. Set the denominator equal to 0. Got my domain. Done and done. Don't do this work if you're not asked to. Again, AP does not do this, therefore we will not. But if you go on in math, this is important to know. But it is not tested on AP, this part. AP does sometimes ask you to get y by itself, so make sure you pay attention to those directions. AP does sometimes say solve the differential equation, even knowing that you have to separate to solve, but sometimes they will insert the word separable. Regardless, if you are supposed to separate and you don't, no follow-through points. All right, last example that we'll do together. So notice again, they told me I have a differential equation, duh, there's a derivative. They do want me to get y by itself when I'm done. Now, remember, a separable differential equation requires a product, and that's not a product. Or is it? Hello, Algebra 1. Factor. And now I have a product, and I have a product where the dependent variable is on the wrong side of the equation. So I'm going to divide both sides by y, which gets me 1 over y on this side, which I turned into y to the negative 1. The dx's are going to cancel out. Probably should have that in parentheses. And now I want you to look at something important here. This is going from here. The next step on is only algebra, but it's important algebra, and it is on the AP exam. Okay, this is going to be important. So anti-differentiating y to the negative 1 is ln of the absolute value of y. Y is not by itself, though, is it? So I raised both sides to the e to the everybody, right? But look at what happens here. You took algebra 2 and you paid attention. Hello, inverses. They undo one another, right? E and ln undo one another. You are just left with the absolute value of y. And then look at this situation. I taught you both of these things in algebra 2, right? E to the ln of 7 is 7. E to the ln of 14 is 14. Exponents and logs of the same base undo one another, and your argument just drops out. I also taught you this. E to the 2 plus 5 really came from e to the 2 times e to the 5, right? Do you remember that? See the base twice with multiplication in between, write the base once and add. Look at what this is. I went backwards, right? Here is my sum. I turned it into e to the x squared over 2 plus 3 to the x times e to the c, right? Make sure you understand where that came from. But you know what? E to the c is just a constant, honey, right? E to the second is just a constant. E to the negative 2, a constant. E to the 14th, constant. But notice it's multiplication between these two things, these two factors, because of exponent rules. But if e to the c is just a constant, I'm going to call it a constant, and it's going to be a multiple. Now remember, how are you going to undo absolute value? Absolute value, right, is just means plus or minus. So y is equal to, right, if I take absolute value out, it's plus or minus c times. Do you see where the times came from? E to the c is just a constant, so call it a constant, but it's a constant times this crap, so I put it in front. Plus or minus, hey, plus or minus a constant is still a freaking constant. So I dropped the plus or minus as well. OMG. That is the solution, the general solution, right? Because I haven't solved for this constant. So maybe C is 2. If you don't believe me, can you take the derivative? Hey, let's check our work. You're telling me that this expression, y is equal to c e to the x squared plus 3x, when you take its derivative, you get this? I don't think so. I don't think so. Well, let's pretend that we solved for c and we got c to be 1. Then my particular solution is 1 times e to that crap. Let's take its derivative. The derivative of e to the stuff is e to the stuff. Spit out the derivative of the stuff. What is the derivative of x squared plus 3x? Bring down the 2, cancel them out. That's where I get x. Derivative of 3x is just 3. That's the derivative. Well, look at what I did here. I distributed the x, and then I distributed the 3. So I got x times that e crap plus 3 times that e crap. Wait a second, what is y equal to? Oh, snap! Oh, snap! Y is e to that crap. This is x times e to that crap plus 3 times e to that crap, which is another way of writing oh, my Lanta. Oh, math is cool. I mean, right? I mean, that just doesn't happen every day. All right. We will do more examples of solving separable differential equations with you in our next live session.